Hello and welcome to the first of a series of short videos on computational physics. My name is Hewell Owen and I'm a lecturer in physics at the University of Manchester. In this first video I'm going to show you the basics of using MATLAB, a very popular language and programming environment for doing computational physics. In front of you, you can see a Macintosh OS X desktop screen, and I've already opened up the applications window and I've installed MATLAB. You can see that MATLAB releases are labelled with a series of numbers which indicates when that release was, and there are also version numbers that go with them. However, despite the fact that there are different version numbers and different operating systems on which you can use MATLAB, they all work in pretty much the same way, and any version from around 2013 onwards will work fine. You will either need to use your own standalone installation or a networked installation, in other words using a network license that you can use if you have the right credentials at the University of Manchester or another university, or you can use one of the local cluster computers which for example are available in the physics department here at Manchester. If you are away from the university network, you will typically need to connect to the network using a virtual private network. So here, if you look on the top right, I've already connected to the university virtual private network, and that means that when I launch MATLAB, I can access the license server. So I'm going to go ahead and do that. I double click and I launch the MATLAB environment. Now, if you don't have the correct licensing, you won't see this window appearing and you won't see the integrated development environment appearing. The IDE, the integrated development environment, is basically a set of windows which allows you simple access to the use of MATLAB and other parts of the system. As you can see, that there is a major window within which there is a thing called the command window. And later on I'll be showing you how to use the other sections of this environment, but for now we're just going to use the command window. Now, if you're using different versions of MATLAB, you will see different layouts of these buttons here at the top of the screen, and different operating systems may look slightly different. But as I said, they will all work pretty much the same way, and most of the features you will need will be available on any version. In the command window, you can see that the command prompt are these two friendly greater than signs, and there's a blinking cursor inviting us to type something. So I'm going to go ahead and type that. I'm going to type 2 plus 2, and that gives me the answer 4, of course. And as you can see, next to the command window on the right hand side there is a thing called the workspace window, which I've just highlighted. And whenever I do a calculation in MATLAB, a variable called ANS is given the value of the most recent calculation, in this case 4. So if I go back to the command window, I'll click on it there and I type in a different calculation, say 2 plus 3, I will get a different answer, the answer 5. So ANS is a so-called reserved word within MATLAB, and MATLAB has many such reserved words. ANS is always overwritten at the end of any calculation, and I can replay or I can regain the answer to the most recent calculation simply by typing in that variable name, ANS. So that's the very basics of using MATLAB, and of course, like any other programming language, there are a number of other features available. Obviously, there are things like functions, so let's try some different functions. We can do 3 to the power of 9. I hit the return key in order to do the calculation, and I get a large number. Let's try a very large number, 2 to the power of 64. And as you can see, the answer is large enough that MATLAB now formats it so that we can display it more conveniently. And in this case, it shows the E notation, so 1.84 E plus 19 means 1.84 times 10 to the 19. In a similar way, if I have a very small number, like 2 to the minus 64, then I see E with a minus sign in front of it to indicate this is 5.4 times 10 to the minus 20. So as well as doing calculations involving simple operations like 2 divided by 3 or 3 minus 5, I can also do calculations that involve functions, and there are many built-in functions, each of which has its own reserved word. So for example, if I want to do the sine of an angle, I can type sine of 30. So when I do that, you can see, aha, it's not 0.5, as I might expect if the sine function was expecting degrees. It's something else, which presumably means that this sine function is expecting an angle in radians. So therefore I can find out what the sine of 30 is, if it's 30 degrees, by doing 30 divided by 180 times pi. And I hit return, and I get 0.5, as I would expect. So when I do this calculation, you can see that pi is again another reserved word, and if I type pi, I see this answer 3.1416. Now, actually, although these answers are being displayed with only 4 digits after the decimal point, MATLAB is actually calculating these values to significantly more precision. And we can see that more clearly by changing the default format with which numbers are displayed. So I'm going to type format long. And when I do this and I type pi again, you can see that pi is now displayed with the complete precision that's available within MATLAB. Obviously, if I were to type format short and type pi again, I would see this abbreviated form, which is a little bit easier to see, but does not show the complete accuracy with which MATLAB is doing its calculations. It's important to note that regardless of the display format, the calculations are always done to the most complete precision that's available within the operating system, which is around about 15 to 16 decimal places per calculation. So I think that concludes the first video. In the next videos we'll go into a bit more detail about the use of functions and then about how to use scripts.